Okay, in the drug rehab center, 32% experienced depression, 26 weight gain, 12 both. Remember, the probability for or is A plus B minus both. So neither depression nor weight gain is basically 1 minus all these using that formula. So if 32 experience depression, 68 don't, 26 experience weight gain, 74 don't, and if 12 experience both, 88 don't. A probability of depression, not depression, plus not weight gain, minus neither, both would be 0.68 plus 0.74 minus 0.88, you get 0.54. The formula for given is, in a problem like this, is both divided by whatever is given. So 0.12 experience both divided by, in this case, given, whatever is given, weight gain, 26% weight gain. So 0.26 to get 0.4615. And then both 0.12 divided by, given that the patient experiences depression, which is 0.32. They are not mutually exclusive and they are not independent. Okay, the probability that drawing a heart then a diamond without replacement, well, 13 out of 52 is the probability of a heart, and so that card stays out. So the next would be, wait, that's wrong. Okay, I had this wrong the first time. So 13 out of 52 that I draw a heart, and it's not replaced, so there's still 13 diamonds left, but there's only 51 cards left in the deck because I did not replace it. Now here, and they're not independent because they're dependent. They're dependent on because the card is not replaced. So if it's dependent, that means they're not independent. This one is independent because I'm putting the card back. So it's basically 13 out of 52 times 13 out of 52, or a fourth times a fourth. There's a fourth of the deck that are hearts and a fourth of the deck that are diamonds. You can do it either way. It doesn't matter. Okay, first one's pretty straightforward. Is not yellow, since 15% are yellow. That means 85% are, remember, they want the answers in decimal form though. So 85% aren't yellow or orange, just add them up. All blue, it just means if 23% are blue, you multiply 3 of them, there's 3. So 0.23 times 0.23 times 0.23. That neither of them are green, since 15% are green, 85% are not. So 0.85 times 0.85, you get 0.723. At least one of them is green, okay? Well, think of it this way. The probability at least one is 1 minus the probability of none, okay, for anything. Probability at least one is 1 minus the probability of none. Well, the probability of none is 0.723, so the probability of at least one is 1 minus 0.723, okay? Okay, these are fractions, so I've got M&Ms here, and there are 18 total, so yellow is 7 out of 18, blue or green. You got 2 green, so 6 out of 18, which reduces to 1/3. There are no orange ones up there at all, so 0. A red candy, then a blue candy if you put the red candy back in the bag. So that means a red candy, which is 5 over 18. And since you're putting it back in the bag, let's see, red, then a blue. Oh, how many blue? 4 blue. 4 out of 18. And you reduce that. 4 out of 18 is 2/9, or here 1/9. So 5 out of 81. Okay. And 2 red candies just in a row if you eat the first one. Okay. So 5 out of 18 times 4 out of 17, okay? Because there's one less of each. So 4, so you go to 2, you got 9 here. So you got 10 out of 153. This I guess we'll do this whole thing, but I want to specifically point out that one there, the part B. Okay, blue or A. Okay, blue or A. Remember, blue or A is A plus B minus both. So blue is 45 out of 132 plus A is 63 out of 132 minus both blue and A, which is right here, 24 out of 132. So add up the top ones, the numerators first, so 45 plus 63 minus 24 is 84 out of 132. And it better equal their answer when I do that, and it does, okay? All right, equals this, okay? Red with that little c means not red, okay? So if you see that red, that means a complement of red. So if that you see that red, it just means find the probability it's not red, okay? So basically, there are 90 that aren't red, all right? So 90 divided by 132, 90 divided by 132.68, yes. B and red, okay? B and red would be B and red, so 22 out of 132, you get that. And B or red, okay? B or red, you do the same thing. B, which is 69, plus red, which is 42, minus both, which is 22, all over 132. And if you do that, you get that answer, okay? When they say given, that's all you're interested in is whatever is given. So given, they got a C. So you aren't interested in anything else except what is given, okay? So in this problem, since given a C, all we're interested in is these C's right here, okay? So given that they got a C, what's the probability that it was a female? So 7 divided by 17. Get that answer. Remember, you're only worried about what's given, okay? And again, it doesn't matter. All you're worrying about is whatever's given, okay? Given that this person's a male. So this is all we're interested in, these 21 people, okay? Because those are the only males on the chart. So B is 7 out of 21 for that answer, okay? And round it to where they tell you to round it, or like 2-3 places. You don't have to go through all these. I don't know why they put their answers like that. I don't know. In this case, I'd go 3 places. They don't really tell you, but most times they do. In this case, they did not. So just go 2, 3, 4 places. I wish they wouldn't do this, but once in a while, it is not specified. But most of the time, they are. Okay, that's a given. That's a given. So when you see that line, that means given. So probability C given female. That's how that reads, okay? So given female, 24 of them. And what is the probability that this female got a C? 5 out of 24, right here, okay? All right. Remember, when you get a problem like this, the equation is both divided by whatever is given. So both is 0.05, A and B, okay, divided by whatever is given A, probability of B given A, okay, probability whatever is given A, and you get 0.1724 when you do 0.05 divided by 0.29. Well, okay, if there's 4 marbles, 1 to 4, 11 marbles, 1 to 11 blue, 1 to 4 is red, and then you choose a number, what if you're told that the marble is blue? So you're told that the marble is blue, so there's 11. That's given. That's a given statement. What is the probability that has a number 2 on it? Well, there's 1, 2 out of 11 blues, so it's just 1 out of 11. The first marble is replaced, another marble is chosen at random. So now, now you have, let's see, you got 11, you got 15. Wait a minute. Okay, so you're told that the number has, it's a number 1. So there's a number 1 of red and there's a number 1 of blue. Okay, so there's only 2 number 1s. So you got a 50-50 chance or 1/2 probability that it's blue because there's 1 red and 1 blue. Okay, this is the probability of that that I randomly draw a bottle that's pink, given that it's an even number. Okay, well, if there's 12 pink, there's 6 even pinks, and if there's 3 red, there's 1 even red. So there's a total of 7 evens. Okay, 6 from pink and 1 from red. Well, what is the probability? Remember, it's given that it's even numbered, so I'm only dealing with the even numbers. Of all the evens, 6 out of those 7 are pink. Well, in this one, you know what? You really don't have to do all this. You could just say, given that because you're given that the student is female, there's 5 that speak French and 5 that don't. But so it's 50-50. But sometimes it is easier to put it in a chart, you know. Okay, so there are 30 students total. There are 10 females, 5 yes, 5 no. Here's French, and total of 10. And there's 20 males, 4 speak French, 16 don't. And again, you don't have to do that for this problem, but it might be beneficial in future problems to write out, just create a chart based on the information given, and then you could answer any question they give you. It's a lot easier to look at it in chart form since we've done a bunch of those. Okay, just because they gave them these as probabilities, it's no different. For or, you do A plus B minus both. So Earth is warming, or is Liberal Democrat. Earth is warming is 0.6. Liberal Democrat is 0.2. And both is 0.18. So if you do 0.6 plus 0.2 minus 0.18, you get your answer here. And oops, didn't mean to do that. Okay, guess I'll just and then given that he is a Liberal Democrat, so Liberal Democrat given, so 0.2, that's the denominator, and Earth is warming 0.18, so 0.18 divided by 0.2 goes there. Given that he is a conservative Republican, so 0.13 goes in the denominator, whatever is given goes in the denominator. That he is a conservative Republican, 0.11, so 0.11 divided by 0.33 is 0.33. Okay, this one I would definitely create a chart. Way too convoluted, way too many questions, trying to do it in your head. So, I mean, if I were you, I created the chart and I wouldn't want to answer this question any other way. You got 31 total students, that goes here. 10 females, so you have up here Spanish speaking, yes or no, and you have males and females. There are 10 females total, 4 speak Spanish, which means 6 don't. Okay, and you've got 21 males over here, that's 21 here. Okay, I'm going to change the color so I could so 21 total males here. Of them, 5 speak Spanish, so that's the number of yeses here. 5 do, then 16 don't. And then now you can just total these. Total yeses is 9, total no's is 22. 9 and 22 is 31, and 21 and 10 is 31. So it all adds up. Make sure all these rows and columns add up to 31. Given that the student is female, so out of 10 females, 4 said yes. What is the probability? Does not speak Spanish, given that the student is male. Does not. So 21 total males, 16 said they do not. I don't know why they asked for percent and say give it as a decimal, but percent of Spanish speaking students are male, so it's percentage of Spanish speaking males. That means yes. If they speak Spanish, that's yes. So given that they said yes, of course, is how you interpret that. It's 5 out of 9. Someone does not speak Spanish. That means no. Probability of females, 6 out of 22.